Alright, now in the previous lecture we have created deletion of a node method in double linked list using Java programming language. Now here we are going to learn how can we delete entire double linked list, and we are going to implement it in practice. Now we know from previous lectures that in case of single linked list, if we set head and tail references to null, then in this case entire linked list gets deleted. But in case of double linked list, this is not the case, because even if we set the head and tail references to null, node 1 will not be deleted, because as I mentioned before, if a node is referenced by any given node, then in this case we cannot delete it from the memory. So this means that if we set head and tail references to null, node 1 over here is referenced by node 2. So node 2's previous reference points to node 1, so node 1 cannot be deleted from the memory. So how can we solve this problem? So in this case, the first thing that we are going to, we have to set all nodes' previous reference to null. So to do so, we know that in case of double linked list, the first node's previous reference is null, so we don't need to do anything over here. Then to set the other node's previous reference to null, all we have to do, we have to traverse through this double linked list over here. So in the first node, we are not doing anything. Then we are going to continue to the next node. Now when we reach the next node, node 2, we are going to set the previous reference of this node to null. Now if we do so, a reverse link between node 2 and node 1 gets destroyed. Then we are going to continue to the next node. So when we reach the next node, we are going to do the same operation. We are going to set the previous reference of this node to null. So this will delete reverse link between node 3 and node 2 over here. Then we are going to continue to the next node. So we are going to repeat the same operation over here by setting the previous reference to null, and this delete the reverse link between node 4 and node 3 over here. Now after doing so, as you see, all nodes previous reference are set to null. So here, if I delete head and tail references, all nodes will become eligible for garbage collection, so it's going to be deleted by garbage collection. So here, the next step is I'm going to set head reference to null. So by doing so, we are deleting a link between head and node 1. Then we are going to set tail to null. So by doing so, the link between tail and last node gets destroyed. Then the first node becomes eligible for garbage collection because first node is not referenced by any given node, so it's going to be deleted by garbage collection. So when we delete the first node, the second node becomes eligible for garbage collection, so it's going to be deleted by garbage collector. Then the third node becomes eligible for garbage collection, so it gets destroyed by garbage collection. Then at the end, the last node is not referenced by any node, so it's going to be deleted by garbage collection over here. Now with these steps, we have successfully deleted entire double linked list from the memory. Now let's see how this is working in practice. Now here inside our double linked list Java class, we are going to implement our last method, which is responsible for deleting entire double linked list from the memory. So I'm going to declare our method like this: public void delete double linked list. So this method will not take any parameter because here we are deleting double linked list itself, so we don't need any parameter over here. Now as we said before, the first thing that we have to do, we have to set previous references of all nodes to null. So in this case, the first thing that I'm going to do, I'm going to create temporary node, which will take the head value, because we are going to start from the first node, loop through the double linked list and set all nodes previous reference to null. So I'm going to write our loop like this. So loop will start from the 0 and it will continue until we reach the size of this double linked list over here. Then in each case it's going to increase by 1 because each time we are continuing to the next node. Then here all I have to do, I'm going to set first temp node's previous reference to null. Then we are going to continue to the next node. So this means that I'm going to set temp node to next. So we are going to continue until we reach the last node over here. Now with this, we have successfully set all nodes previous reference to null. So after doing so, we have to set head to null and tail to null because we have to delete the link between head and first node and tail and last node. Then we are going to print out to the console saying that the double linked list has been deleted. So DLL has been deleted. Now with this, we have implemented a method of deletion of double linked list. So here, as I mentioned, first we are setting the previous references of all nodes to null, then we are setting head and tail to null. So with this, we are deleting the link that are referencing to any given node over here. Now let's see how this is working in practice. So as you see over here in our previous lecture, we have created double linked list, then we have inserted 3 elements to double linked list, then we are traversing through double linked list. So after traversal, I'm going to put delete DLL method. Then after that, I'm going to call traversal method one more time to see that if we have successfully deleted or not. So if I run our code, you see that first it's printing out the double linked list, which comes from this traversal method. Then it says that the double linked list has been deleted. Then if I call one more time traversal method, it says that double linked list does not exist. So this means that our method has successfully deleted the double linked list from over here. Now from here we can see that deletion of double linked list method works successfully. Now let's see what's the time and space complexity for this method over here. So as always, we are going to start from the first line of this method. Now in the first line, we are creating temporary node and setting head value to it. So this part of code will take O1 time complexity because here we're just creating a node and assigning a value to it. Then we have a loop over here in which we are looping through all elements of double linked list. So if the number of elements in double linked list is n, so the time complexity for this loop will be O n. Now inside this loop, we are setting the previous reference to null and temp node to temp node.next. So this means that these 2 lines of code here will take O1 time complexity. Then we are continuing to the next line of code. So in the next line of code, we are setting head to null and tail to null. So these 2 lines of code also will take O1 time complexity. Then at the end, we are printing out message to the console. So this one also will take O1 time complexity because this is not time consuming operation. Now if you combine all these complexities over here, we get On time complexity because in this case, On is dominant term. Now the space complexity is O1 because in this case we are just deleting all nodes from the memory. So this is not space consuming operation. So that's why space complexity is O1. Now with this, we have come to the end of this lecture. So in this lecture, we have explained how can we delete entire double linked list from the memory, and we have implemented it in practice. So hopefully everything is clear about this lecture. So see you in the next lecture.